Ladies and gentlemen, welcome on today's episode. We'll be delving into the gravitational potential energy, which is capital V, uppercase V. Thanks for tuning in, and if you enjoyed this video, don't forget to like, share, and subscribe for more educational content. Keep learning and keep growing. Now, have you asked yourself, have you watched and see a bird sitting on a tree branch or a flower pot hanging off the deck? Or have you seen an apple hanging in a tree, a plane flying overhead? All these are effects of gravitational potential. So, gravitational potential energy, the hidden force. Gravity, a fundamental force of nature. It plays a crucial role in shaping our universe. Gravitational potential energy is a concept closely tied to gravity. It is the energy an object possesses due to its position or height in a gravitational field. The concept of gravitational potential energy is essential in understanding various phenomena in the natural world, from the motion of projectiles to the behavior of planets in our solar system. Gravitational potential V is the potential due to the gravitational field of the Earth. Definition: it can also be defined as the work done in taking or bringing, underline, in taking or bringing a unit mass from infinity to the point that is a particular distance from the center of the Earth. So gravitational potential energy is a form of stored energy that can be converted into kinetic energy when the object is allowed to fall freely under the influence of gravity. This conversion of potential energy into kinetic energy is responsible for the motion of objects falling to the ground. How do we calculate problems under gravitational potential energy? Remember that work, which is effort, is highly required to be applied. Gravitational potential V at infinity is zero. Body as objects having a mass m happens to be at the receiving end as the object. There is always a point of origin to a point of destination, which is distance. A place at infinity to another place on the Earth. The distance, which is the potential energy, decreases. It becomes more negative as the body is moved at a distance r, lowercase, from the center of the Earth. So, gravitational potential energy, or an energy GPE, is the energy a mass or an object placed in the magnetic field has. The object experiences energy or the exertion of energy by placement into the magnetic field, which is the Earth's gravitational force or field. So, the formula, mathematically, gravitational potential V is equal to work done per unit mass. So, you know that V is equal to mgh divided by m. That is, the mgh is the gravitational potential energy divided by the unit mass m. So mgr, substituting h for r, is mgr divided by m is equal to gr. Or g is equal to, recall, Earth's gravitational constant, which is capital G multiplied by capital M divided by r squared. Therefore, V is equal to gm, all upper cases, divided by r squared multiplied by r. At the surface of the Earth, where lowercase r is equal to uppercase r. To see how this relates to the simpler formula, we can rewrite or write that lowercase r is equal to uppercase r plus lowercase h, which is the height, where uppercase r is the radius of the planet and is the distance of the object from its surface. Plugging these into our first formula, we obtain V is equal to gm divided by r. The gravitational potential V at any point is given by V is equal to negative gm over r. M is equal to the mass producing the gravitational field. Lowercase r is the distance between the point and the center of the mass, and hence the formula for gravitational potential energy is V is equal to mgh. Recall that g is the acceleration due to gravity, approximately 9.8 meter per second squared on the Earth, and h is the height or position of the object in the gravitational field. So the potential energy at infinity is taken as zero by conversion. The negative sign indicates that the potential at infinity is zero, and it is higher than that potential energy close to the mass producing the gravitational field that is towards the Earth. So what are the triune components or properties of gravitational potential? Number one, work. The work done on the mass is W is equal to potential energy and is equal to mgh. Number two, energy is required, and this energy is associative. Number three, force is required. The force applied to the object is an external force from outside the system. So if you compare gravitational potential or gravitational potential energy with escape velocity, you realize it's as if they counter each other. Escape velocity is to take a body from the Earth's realm to infinity, while gravitational potential is to bring a body from infinity to the Earth's surface. So gravitational potential undo the effort or effect of escape velocity. Applications. Gravitational potential energy has numerous applications in various fields. This includes hydroelectric power plants. How does this occur? Water stored behind a dam has a high gravitational potential energy, which is converted into kinetic energy as it flows down, generating electricity. Number two, roller coasters. The gravitational potential energy of the roller coaster car at the top of the hill is converted into kinetic energy as it descends, providing the thrill of the ride. Number three, satellites. Satellites in orbit around the Earth have a high gravitational potential energy, which is balanced by their kinetic energy, allowing them to remain in orbit. Therefore, in conclusion, gravitational potential energy is an important concept in physics that describes the energy stored in an object due to its position in a gravitational field. Understanding this concept allows scientists and engineers to predict the behavior of objects in a gravitational field and make accurate calculations in a variety of practical applications. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped. Stay liquid.